Good morning, good evening, good afternoon. Today we are going to continue the second part of the Higgs boson and the Higgs field. Vacuum expectation value, or VEV in short, is the average value a field can take in an empty space. And for Higgs field, this lowest energy state is not zero. The VEV of Higgs field is The VEV of Higgs field is 2.46 into 10 to the power 11 electron volts. This phi is the symbol of the Higgs field, and these brackets are the symbol of expected value. Or this we write 246 giga electron volt, and this is just an estimation. We cannot be sure about the actual value. This was not the energy of the Higgs boson in vacuum, because in vacuum the energy of Higgs boson is energy for Higgs boson. This H0 is the symbol of the Higgs boson. Its energy in vacuum or rest state is 125 giga electron volt. And how do we find the mass of Higgs boson? Since you already know the energy, that is 125 giga electron volt, using the world's most famous formula E is equal to mc square, we can find its mass. We get the mass as 125 giga electron volt divided by the speed of light, but this doesn't seem right, so I'll expand it in scientific notations. So the mass of Higgs boson is 2.228 into 10 to the power minus 25 kilograms. Do you know why it was so hard to find Higgs boson? Because its lifetime was very short. We could not detect it. Its lifetime is only 1.6 into 10 to the power minus 22 seconds. I am sorry, I forgot to mention the formula of Higgs potential in the previous video. In that video we had only learned this formula, but there is another. This one formula is different because we had modulus and changed the powers of the phi. We know that particles get their masses depending on how strongly or coldly they interact with the Higgs field, but we have a formula to find the mass of particles by this interaction. Or instead of the term interaction, rather we use the term coupling strength. In this equation, this is the mass, this is the Yukawa coupling Y, and this V is the Higgs field value divided by a radical. Higgs boson were discovered by the use of particle collider. How were these particle collider used? So there are several different particles. We can collide these particles and then observe them under special equipments. Many of the particle combinations give rise to the Higgs boson. The first one, the most commonly used to form the Higgs boson, that is gluon-gluon combination. If you combine gluon and gluon, you get the Higgs boson. And apart from this, we have many others, like there's one called the vector boson fusion, in which we collide the W bosons to get the Higgs boson. Positive W boson, negative W boson give rise to a Higgs boson. And there's another way in which we involve protons. So first one, if we collide a proton and proton, we may get these two results, and notice here that the input is same, but we get, in the first case we get the W boson along with the Higgs boson, and in the second case we get the Z boson along with the Higgs boson. Now the last one, in which the product obtained is a quark anti-quark combination. So if we collide proton and proton, We get top quark and anti-top quark pair along with the Higgs boson. Depending on different circumstances, we get different products along with the Higgs boson. That was it for today. Goodbye.